Hugging Face is an AI community and platform that serves as a central hub similar to GitHub for machine learning models, datasets, and applications. We have found the perfect dataset on Hugging Face, but it's massive, and pandas just crashed. What do you do? In this video, I will show you 3 distinct methods to load any Hugging Face dataset directly into PySpark, from the simple and direct way to the most efficient, large-scale approach. Let's get started with method 1. So make sure to firstly run all these code cells to make sure we have all this Java environment variable, and also we have PySpark with us, and then we need to initialize Spark context. So then we need to get familiar with Hugging Face dataset. If you come over here on Hugging Face website, and if you go through datasets, you can see there are so many datasets. You can use this filter on the left hand side, or you can get your desired filtering on data and find your data accordingly. Let's say that in this tutorial, we are going to work with this Amazon review full, and then you just need to look it up and get this dataset. As you see that this dataset comes with 1.63 gigabyte in size, and you can get an overview of this dataset. And there are so many information that you can collect through the available links. We can bring everything directly here on the Jupyter Notebook, so you can import this HTML library, and then you can write iframe in the HTML format. Let's say that here we have a direct link. This is exactly this link, all right, but we need to add a few more stuff. So firstly, dataset, let's make it here dataset as the variable to get control everything accordingly. So you need to copy this link and then come over here and paste this dataset. So, and then we need to add these 2 keywords after dataset to make sure we are able to plot data accordingly. And then make sure here to mention where is dataset. Dataset is our dataset. All right, and then we can display. All right, display HTML iframe, this iframe for us. And then if you run, you can see that here you can call Hugging Face directly, and then you can get familiar with this data. So there are so many information like the training data, 3 million rows, and testing data, 650k rows, and then additional information. Let's say that you want to keep going. You can add one more code cell. Let's say that you want to try dataset 2. Dataset 2. I'm targeting this dataset, IMDb. As usual, you need to copy this dataset and then come over here on the Hugging Face and then paste it. So the same thing we did here. You can copy this iframe, we can copy the full iframe, and then you can come down here and then paste it. Make sure that this dataset here, this one is dataset 2, right? Because of this dataset. And if you run it, you can also see this dataset accordingly, right? About how many splits there are, and you can get familiar with this attribute. So the most and first straightforward method is to download the data and load it into an RDD. It is simple and works great for medium-sized datasets. Let me show you. Here we need to say data. We can use this load dataset, and then I want to load this dataset. The first one we went through, right? I'm talking about this Amazon review. So you come over here, and then you need to decide which part of data you want to take over, the training data or testing data, right? There are 2 splits. I would like to work with train data. Train data, please, I need you, data, and then train. All right, and then if you want to run this cell, you see that it comes up with a message. This warning message appears because you are using the Hugging Face library in Google Colab without being authenticated. So Hugging Face recommends using an authentication token for private datasets or to avoid rate limits when accessing public resources. So, but this step is optional, right, for public datasets. But we can ignore this message. Let's finish this step. You see that he's going to get access to training data, testing data, and then we are asking to please, we need to get only training data. All right, you see that if we say train data comes with these three: label, title, content, right? We need to get this content. So let's make it modified. It means that here I want to go with one more cell. I want to say import warnings, and then I want to say that warnings dot filter warnings, please ignore category. So user warning for module is Hugging Face hub.utils authentication. All right, and then we go with the rest. I'm copying this one, come over here, and then I want to say try. All right, this dataset firstly. All right, and then here I want to say that all content data is going to be this train data. As I mentioned, we need to get only content, right? And then we can print a message, print file successfully imported. All right, and then here, if we get error for any reason, we can say that exception as E, and then please print the error to see what is this error and what is the class of this error. All right, to underscore. And if you run this one, all right, file successfully imported. Okay, so now we can go with one more cell, and then since this data is with us now, what we can do, we can write a loop for I and review in enumerate all content data, start this enumerate counter from 1. Let's print just first 10 records to make sure data is with us. If I is less than 11, please print f score, please. I is the counter. We set that to start from 1, and then we can do something like this, and then review. All right. Else means break this loop for us. All right. If you can run it, you can see that we could collect, the first 10 records accordingly. So what we need to do now, we need to save it, right? Save it and then use it again. So we can write the Python function, and then here we set that reviews.txt. I want to write it in this file, so please write it for me as file. So for review in all content, all right, then filter, and then say file dot write. What to write? Please write for me this one, F format, and then please write this review \n means go to the next line once you finish each line, and then run it. So if you run it, you see that this file is coming here because we said that write it in a file. because we get the file, we get data, and now we need to store it somewhere for our usage. Let's say that you want to do some filtering on data, you want to prepare your data accordingly, and then you can write it somewhere for your own purpose. So since it's writing the file, let's add one more cell. And then here we need to decide to how to use this data, right? Our assumption is data is huge, and you saw that data comes with 1 GB volume. So RDD is Spark context dot please text file, please read this file for me, review. So we need to wait because it's still working, still writing data in a file. Since syntax is Python, you must be very careful that if size of data get increased, then you might get a message like out of memory message, right? Be careful about this. Review txt, right? And then go with 8 partition, please. To make sure these are all with us, let's take the first 5 records accordingly. All right, data is with us, right? The first 5 record is here. To test that everything is really great with us, we can write a simple RDD syntax. Let's say that we want to find the longest word, all right, in this RDD. So I would say that longest word is going to be first. So we need to go with flat map. So lambda and then line. So please first split each line. Go to the next line, please. And then after that, please radius, right? We need to aggregate it. Lambda A and B. So if the length of A is greater than the length of B, please choose A. Otherwise, go with B. Right? That's it. And then I would say print F format. The longest word is, and then here I would say this longest word. And also, if you wish to see how long this syntax take over to get Python and PySpark for processing, you can add this to percentage time to also measure the time taken. All right, you find it out. Longest word is this word, and it takes about 1 minute and 41 seconds on Google Colab with 2 cores. It seems this direct method is simple with flexible pre-processing, but it's very memory intensive, and we need to take some intermediate steps to prepare data, collect data, save data, and then read data again on Spark. So it seems this is the great method for small to medium size dataset. But what happens when the dataset is 100 gigabytes, 1 terabyte, 10 terabyte? Saving it to a local text file first is inefficient and creates a bottleneck because Python gets crashed. So for true big data, we need a better way. The better way is using Parquet files. Before we code, let me quickly show you why Parquet is so powerful for big data. A Parquet file is a columnar storage format in the Apache Hadoop ecosystem designed for efficient storage and processing of large-scale data. It supports advanced features for faster query execution, like compression, schema evolution, and metadata storage. Let's say that if you have 100 megabyte data and if you convert it to Parquet file, means convert it to column format and compress it, your file gets into about 10 to 20 megabyte. If your data is 1 gigabyte, with Parquet file, you can make it to 100 to 200 megabyte with 10x compression ratio. which is very typical for analytical data. And if you have 1 terabyte data, you can convert it to 100 to 200 gigabyte. It's a significant size reduction with compression. Let's take this example. We have this table, 3 rows, 4 columns. If you get row-based data storage in disk, this is how we can have data back to back in a row basis. But if you get column-based data storage in disk, this is how we can have this data. Let's consider this SQL query. Select all from loans where ID is 2. It seems this is good performance for row-based format and bad performance for columnar format. But if we come up with aggregations, select some amount from loans. It seems bad performance for row-based format, but it comes with really great performance for columnar format. If you would like to filter rows based on specific columns, if you have aggregations like summation, average, if you want to do queries with a subset of columns, if you want to do large analytical queries, we can go with Parquet files. But if you want to fetch all columns of a specific rows, we can work with traditional mode, row-based dataset like CSV file. If you want to do insert, update, delete operations, and if you wish to do joins between tables, row-based is still the great choice. So let's jump into the coding. So for Parquet, we need to firstly look up for a data set that Parquet file is available. I'm going to take this data set, right? That what you need to notice here, you need to make sure that there is, say, size of auto-converted Parquet file. It seems the Parquet file is also here with us. All right, and then as usual, we need to copy this link, come over here and say data set, right? And my data set is this Hugging Face. All right, and then we need to go ahead with API. Here we need the API for Hugging Face, basically for Parquet. So Hugging Face Parquet file, let's say Parquet API. So it means that from this data set, we need to get exactly, the same stuff. All right, but we need to do a bit of changes. So it means that here you need to paste it, but here Hugging Face. So then before dataset, we need to say API because we are going to work with Parquet file dataset, and then here we can remove this one. All right, and then we said, okay, this is dataset. All right, as we mentioned here. And what else? I need to get a Parquet format, please. So now let's get the Parquet file. So get the Parquet file URL. So if I say R is, so we need to import one more package here. We need to say import requests, all right, to be able to download this data. So requests, please get this Hugging Face API. All right, and make sure that this is with this format, that dataset is dataset, please. All right, and then I would say that train, let's say train, or maybe if I just say print R, let's see what we get it firstly. And if you run this one, it says response 200. It means that we need to open it up. Let's open it up with JSON. And if you come with JSON, you see that it says it comes with a JSON format. This is how we usually have Parquet files. Default train. So this is dictionary. It means that if you want to get this to your Parquet file and you see that there is only one Parquet file starting with index 0, right? You just need to get access to default train. How to do so? You just need to say here, I need to get to default key, and then in the default key, the value is train key, right? And let's name it train Parquet files. And that's it. If we run, so great, right? Parquet is now with us. What we need to do, here we need a Spark session, not a Spark context. So from PySpark.sql, please import Spark session for me. And then here we need to initialize a Spark session, right? This is how we can work with Parquet file. So Spark session.builder. So go to next line. So why not to go with app name? So let's say load Parquet file to PySpark data frame. And that's it, right? Get or create. Then we can insert a new code cell, and then we can call this this Parquet file, df spark.read.parquet. So I want to read this train Parquet file, please. All right, and then df.show. Let's run it. All right, we get error. So what happens? PySpark cannot read from an HTTPS link directly, but there is a clever workaround using Spark files. Let me show you, then present the correct code. Okay, how we can make it correct? You can come over here. It means that we need to ignore this one, right? Let me turn it off, comment it. So then you need to come over here, and then you need to say from PySpark, please import Spark files for me. All right, and then for, let's say, URL in train, I mean this one, right? In train Parquet file, now spark.spark context.add file. This is how we can import the Parquet file, right? And done. Then we say that df please spark.read.parquet spark files dot get root directory, and then plus. So then here you need to say which file you want to collect. We know that this is 0.parquet, right, the extension, or if there are many Parquet files, so you can use asterisk. You say, all right, please collect all Parquet files. All right, and df.show, and here we go. Great, right? Data is here now with us. You can do your further analysis. Let's say that you want to do repartitioning, df.repartition to 4 partition. All right, and then after repartitioning, let's say that you want to write a query group by reasoning. I'm talking about the first attribute, reasoning language, and then count it, and then order by this count, right? Let's say that I want to say ascending, true, and show the result accordingly. Great job, right? You can see that. How is that fast? Because of Parquet file, we compress data, and it's going to really save the time and the time complexity is really minimum. So it seems Parquet is efficient and optimized for big data, but the problem here is HTTPS compatibility issues, right? We need to set up something, and it's going to add, a bit of overhead. But this is really great for large data set with Parquet availabilities. It seems method 2, Parquet is very powerful, but it required a few manual steps. But what if I told you there is a library that handles everything for you with just one line of code? This is where the official PySpark Hugging Face library comes in. After a quick install, you can load a dataset directly into a data frame. Let's kick off. So it means that here we need to say pip install PySpark Hugging Face, right? So we need to also import operating system, because once we install this library, we need to restart the runtime. Print, let's say restarting the runtime to make sure this library is with us. So how to do it? We need to kill the current process. So whatever is going on this Google Colab, please kill everything for us. Get PID. So, and then please use 9 to, it's like a system signal used to immediately terminate a process. So let's run this cell. All right, it's going to work accordingly. So installing PySpark Hugging Face for us. So great job, we could successfully install, and you see that, messages here come in, right? So then we need to say import PySpark Hugging Face, right? Let's import. Since we killed all libraries, we need to again load PySpark.sql, import Spark session, and Spark is going to be Spark session dot builder dot app name. Let's name it PySpark Hugging Face. All right, get or create, and then df is spark.read dot. Here we need to say format. Okay, what is the format? The format is Hugging Face. Hugging Face. Where is this Hugging Face? Load, and then which data set I want to work with? This Amazon review, right? Let's get this one, the full path. Come over here and then paste it. It seems very easy, right? Compared to other methods. And then I would say df.show to see what's going on. Great, data is here with us, right? You can keep going with your analysis. It seems PySpark Hugging Face is optimized for PySpark with minimal code. This is really the great advantage. But it requires additional library, and it comes with limited customizations. But that's really great method for direct loading into PySpark data frames. So we have seen 3 different methods. Which one should you choose? If you find this helpful, please like the video and subscribe for more tutorials on big data and machine learning. Let me know in the comments which method you will be using.